In this video, we are going to go over some harder limiting reagent questions. So if you haven't checked out the first part of the video on limiting reagent, please go and watch it. I will link it down below for you. Once you finish watching that, please continue with this video. Okay, here's our first practice question. How many grams of sodium hydroxide is produced from 120 grams of sodium oxide and 120 grams of water? Now, before I do anything, you want to double check whether this is a limiting reagent question. So this is a limiting reagent question because both of the reagents, more than one reagent value is given to me, right? So sodium oxide and water, they both have a values given to me. So with that being said, I will need to come up with the limiting rate, determine which one is the limiting reagent first before I start finding out how many grams of sodium hydroxide is produced. So again, just like anything, if the chemical equation, the balanced one, is not given to you, you need to come up with the balanced chemical equation first as your step one. And then step two is to determine the limiting reagent. Now, a common mistake a lot of students make is that they will just directly compare 1.20 times 10 to the power 2 grams of sodium oxide to 1.20 times 10 to the power 2 grams of water. Unfortunately, this is not correct because remember, sodium oxide and water, they will have different molar masses. So with that being said, the number of moles might be different depending on the molar mass. So with that being said, the next step should be determining, converting everything into moles, and then from the moles value calculated, you can determine which one is the limiting reagent. So this is exactly what I did here. I have 120 grams of sodium oxide. Now you know what to do. This is just moles conversion here. What I will do here is I will multiply the inverse of the molar mass or divide by the molar mass to find the number of moles of sodium oxide. Same thing with the water. So I have 1.94 moles of sodium oxide and 6.67 moles of water. Now, remember, you have to ask yourself the question. How many times can you repeat the recipe given each reagent? So to answer that question, I know that if I have 1.94 moles of sodium oxide, I should be able to repeat the reaction 1.94 times. Since per recipe, per reaction, I will need to use one sodium oxide. So that's why 1.94 divided by 1 is 1.94 times. Same thing with water. Given that I have 6.67 moles of water, and each reaction, each recipe, I would need 1 mole of water. So with that being said, how many times can I repeat the reaction or the recipe? Well, it'll be 6.67 times. So with that being said, your limiting reagent is going to be sodium oxide, since 1.94 times will be less than 6.67 times. So once you determine the limiting reagent, you will need to complete this BCA table. Okay, so again, we will focus on solving. Let me just have a pen right here. Sorry, my pen is out of battery. Just give me a quick second here. Okay, so we will have, usually the easiest way to do it is to fill out the column for the limiting reagent first. So to start with, I have 1.94 moles of sodium oxide given by the question. I know that for limiting reagent, I should be able to use up everything. So afterwards, I should have none left. So that's why I will have negative 1.94 moles here. And then what I do here is to come up with a 0 is just 1.94 minus 1.94 or 1.94 plus 1.94 moles. Now moving on to water, I have 6.67 moles given to me. But since this is an excess reagent, I won't be using them all up. So how much do I consume? So go back to the last video, right? You have to go back to the mole ratio. And this is also what we have been talking about in class. In order for you to convert from chemical A to a chemical B, basically from one chemical to a different chemical, you will need to go through the mole ratio, your balanced chemical reaction. So it will be minus 1.94 since I'm consuming moles of sodium oxide. The mole ratio between water and sodium oxide is 1 to 1. Therefore, negative 1.94 moles will be the change. So because it's consumed. So don't forget that negative over here. So if I do 6.67 plus negative 1.94, that will be equal to 4.73 moles. Now, how about sodium hydroxide? Again, this is a product. So since the question didn't say we have already made some, so we can assume that there's none to begin with. And then as the reaction, as the recipe progresses, as the reaction progresses, we should be making sodium hydroxide. And again, the amount of sodium hydroxide produced will be determined by the limiting reagent. So what I would do here is I would do 1.94 moles of sodium oxide multiplied by the mole ratio between sodium hydroxide and sodium oxide, which is 2 to 1, and that should give me 3.88 moles. So 0 plus 3.88, that will give me 3.88 moles of sodium hydroxide. Now let's take a look at a harder example. So here's the question. If you start with 56.8 grams of aluminum 2 chloride, 14.0 grams of potassium nitrate, and 40.0 grams of hydrochloric acid, and mix them together and allow them to react according to the recipe, the balanced chemical equation below. And the question asks you, what are the limiting reagent and excess reagents? How much in excess is the excess reagent? So again, you have the mass of more than one reagent given to you. This is a classic limiting reagent question. And also the question itself kind of gives it away. So with that being said, what I need to do first, since the balanced chemical equation is given to me, so the immediate next step is to convert everything into moles first. Now, to save time, I already converted for you. So, and by the way, there's no way I can just directly compare 56.8 grams to 14.0 grams and 40.0 grams. Why? Because these chemicals, they're different chemicals. They will have different molar masses. So even though 14.0 grams of potassium nitrate seems to be the least number of amount of reagent given to you in mass, we cannot know for sure until we convert everything into moles and compare the number of moles. So this is actually what we do here. So to save time, I converted iron 2 chloride from 56.8. You just need to divide by the molar mass to find the 0.448 moles of iron 2 chloride. Now again, that famous question, to do any sort of limiting reagent question, how many times can you repeat the recipe given each reagent? So here, if I have 0.448 moles of iron 2 chloride, I should repeat the reaction or the recipe 0.149 times. Now, how do I come up with that number? It will be 0.448 moles divided by 3, because per recipe, per reaction, I need 3 iron 2 chloride. And if I have 0.448 moles, it will be 0.448 divided by 3, so 0.149 times. I'm going to repeat the same thing for potassium nitrate as well as hydrochloric acid. So first, find out the number of moles of potassium nitrate by dividing the 14.0 grams by the molar mass of potassium nitrate. And given 0.138 moles of potassium nitrate, I should be able to repeat the reaction 0.138 times, because per recipe, per reaction, I need 1 mole of potassium nitrate according to the balanced chemical equation. So I'm going to do the same thing with hydrochloric acid. So I have 40.0 grams of hydrochloric acid. That means I should have 1.09 mole of hydrochloric acid. Now, given 1.09 moles of hydrochloric acid, I should be able to repeat the reaction 0.272 times, because per reaction, per recipe, I have 4 moles of hydrochloric acid. So if I have 1.09 moles of hydrochloric acid, I'll use 1.09 divided by 4. I should be able to do the reaction 0.272 times. So now comparing the number of times you can repeat the recipe or the reaction per reagent, so 0.149 times, 0.138 times, as well as 0.272 times, which one is going to be your limiting reagent? In this case, it's going to be the potassium nitrate. Now again, just because it's somehow potassium nitrate is also has the least number of mass in grams, 14.0 in grams, it doesn't mean that that's always going to be the limiting reagent. You still have to convert everything into moles first, and then answer that question, how many times you can repeat the experiment given the number of moles, given the number of moles of each reagent given to you, before you can finally make the conclusion for potassium nitrate to be the limiting reagent. Okay, so be really careful here. That's the common mistake students tend to make. So with that being said, the other two reagents should be in excess. But of course, the question asks you how much in excess is the excess reagent. So that's what we're trying to find out. So let's do it. So again, limiting reagent is 0.138 moles of potassium nitrate. So again, the amount of each reagent, each excess reagent consumed should be determined by the limiting reagent. Same thing apply for the products produced, should also be determined by the limiting reagent, the amount of limiting reagent. So that's exactly what I do here. I started with the 0.138 moles of potassium nitrate, and I multiply by the mole ratio that I get from the balanced chemical equation between iron 2 chloride as well as potassium nitrate. And since the question is kind of implying that you have to convert it into mass so that you can just find out the leftover by subtracting the initial amount of iron 2 chloride in grams by the amount used. So this is what I did here. I just multiplied by the molar mass of iron 2 chloride, and that's 52.5 grams of iron 2 chloride used or consumed. So to find out the leftover amount, I will have my initial subtracting the used amount. So it's going to be 56.8 minus 52.5. That will give me 4.33 grams of iron 2 chloride left over. Now let's do the same thing with hydrochloric acid. Again, 0.138 moles of potassium nitrate multiplied by the mole ratio between hydrochloric acid as well as potassium nitrate. Then you multiply by the molar mass of hydrochloric acid. And that will give you, that setup is going to give you the amount of hydrochloric acid consumed or used. Now to find out the leftover amount, you need to have the initial amount, which is 40.0 grams, minus the amount of hydrochloric acid consumed, so 20.1. That will give you 19.8 grams of hydrochloric acid left over. Now, of course, I could also ask you this type of question. What if the question says if 2.33 grams of water is produced in the lab, what is the percent yield? Well, remember, first of all, the amount of product made will be determined by the limiting reagent. So since the limiting reagent is potassium nitrate, so the amount of water produced will be determined by the potassium nitrate as well. So 0.138 moles of potassium nitrate multiplied by the mole ratio between water and potassium nitrate and multiplied by the molar mass of water, that will give me 4.97 grams of water produced. Now you probably will be wondering, hold on a second, what am I doing here? Why do I need to do this operation here? Well, we'll call that percent yield. To calculate percent yield, the formula here is you will have the actual yield divided by the theoretical yield, multiplied by 100%. Now, what is actual yield again? Actual yield is what you actually produced in the lab. This is a measured value. Keyword, measured. So you did the experiment, you mix this amount of chemicals, 56.8 grams of iron trichloride, 14.0 grams of potassium nitrate, and 40.0 grams of hydrochloric acid in the lab. But of course, again, in theory, on paper, the amount produced will be different from what you actually produce in the lab due to experimental errors and things like that. So the actual yield is what you actually produce, the measured value, which is 2.33 grams of water, given by the question. And the question will always give you that. Otherwise, there's no way you can figure it out, the percent yield, without the actual yield. Now, what is the theoretical yield? Well, the theoretical yield is what you expect to produce, the calculated value from stoichiometry, okay? So 4.97 grams of water was calculated from 0.138 moles of potassium nitrate. This is what we think it's going to produce on paper. But in the lab, again, because of experimental errors, we may not be able to produce 4.97 grams. Instead, in fact, right now, it's telling me we produce 2.33 grams of water. So here it is. To clean it up, plug the numbers in, replace the actual yield with 2.33 grams, and then theoretical with 4.97 grams, divide the two number, multiply by 100, that will give you 46.9%, and that is the percent yield of water. So hopefully you have a pretty good understanding of how to find limiting reagent in chemistry, and also how to find the percent yield given the amount of product produced in the lab, the actual yield. So again, as always, if you like this video, don't forget to give me a thumbs up. And there should also be a worksheet posted on Teams titled Worksheet 7 for you to complete. It should be under the class notebook worksheet. So until then, if you have any questions, feel free to reach out.